the next session? Hello, good morning. For those who are remote, good afternoon, good evening. Appreciate everyone being here physically and online. We have some nice participation in the room and some nice participation remote. Please let us know if there's any audio problems for those who are remote. Want to make sure everyone can participate equally. Okay. Can you hear me? All right, let's try again. Is that good? Hopefully everyone online can hear me as well. I was saying we have good participation in the room and remote. We're going to try to make it very equitable for all. So if there's any problem, please type in the chat. For those in the room, we are going to try to use the online tool. You can scan the QR code. So we're going to try to manage the queue integrated between remote and local. I'm Lou Berger. We have Pavan Biram, my co-chair, and Luis Contreras here helping out all in the room. It's very nice to be back. Well, we have our note well. It's the first meeting for me at this IETF. I didn't participate in anything yesterday, so I'll mention it. This is our rules for participation. Basically, everything you say and do here becomes part of our record. If you're not familiar with the note well, please go look at it at the link right off the IETF page. In the past, we've been asked to remind the working group about how we treat each other and to make sure we treat each other professionally and with respect. We weren't asked to say it this time, but we thought it's a good habit to keep reminding the working group. I've already talked about us being online and also in person, and that we're going to be managing the queue. If you don't know how to get the tool, go to the QR code that's on the backs of several of the chairs, or go online and you can find it at the agenda. I think we've probably hit all of these things already, with the exception of the note taking. We are doing collaborative note taking as we generally do. Please jump on the link, and that's shown here, and I'll drop it into chat in just a moment, or someone else will for me, and help make sure that what we say here is accurately captured. You don't need to capture what is being presented, just the discussion around the slides and around the topics. We have a pretty packed agenda, so I'm going to keep going forward. So, we're here to produce documents. So this gives us a little bit of a taste of where we are. We don't have any new RFCs, but we do have one in queue. So that's great. Thanks for all who contributed to that. We have a couple of documents that are post last call. The first one, there was a bit of technical change during the last call, and it hasn't hit the level of saying we need a second last call, but it's hit the level where we want to give people ample time to respond to it. I know I have one comment that I personally haven't gotten to, and I promise I'll get to it this week. But if everyone can take the opportunity of being here this week, take a look at it. Adrian's here, he's the editor. If you have something you want to discuss, corner him, or just send it to the list. The PCC use cases, that's been around for a while. That should be submitted soon. We also have several documents that have gone through adoption recently, and one of them we're going to talk about later. We did receive one incoming liaison. It is somewhat interesting. They are not asking for any response, but it is worth noting that it came in, and take a look at it and see what this other SDO is doing in areas we are working on. Not surprising, it's on slicing. As always, we remind you that we continue our working remote, working in hybrid mode. We have working group resources that are available to anyone in the working group. If you're interested, just contact the chairs. When you send it to the alias, it'll hit the three of us, and we can take action on it. And just as always, it's good to remind everyone of our RPR process. One of these years, we'll remove new step. We've had that new step now for a few years, so we should not call it new, but um, and with that, I think we're going to move to the next slide.
Good morning. Can folks at the back hear me okay? Can I get a thumbs up from the folks at the back if you can hear me okay? I'm Pawan Biram. I'm your other co-chair. Before I start walking you through the working group document status, let me thank our working group secretary, Louis, for collating all the status reports and putting the slide deck together. Next slide. We have 26 working group documents. They're all listed here. There are 3 documents that are colored in blue here that are on the agenda today. There's one, the GMPLS extensions for shared mesh production. That's in the RFC 8S queue. That leaves us with 22 documents, and the status of all those 22 documents are covered in this deck. That includes the 4 documents that we just adopted, and also the 2 for which we successfully completed last call in recent weeks. Um, Given the packed agenda, I will not be going through the status of each and every one of these documents, but I will, however, double click on a select few which we believe need some immediate attention. So let's start with slide number 3. Um, this is the ACTN performance monitoring document. This is getting ready for last call, but the authors have stated that they have run into some issues with respect to XML validation and are seeking some help from the working group. Authors, if you can elaborate a bit more on what is the kind of help you're looking from the working group, that you will be able to find some volunteers to help you with that. If this is a young tooling issue, you may want to reach out to the young doctors or the NetMod working group. So Drew or any of the authors here in this room, would you like to add to what I just said?
Thanks, Pavan. The only thing that I would like to say is like anybody who has a good setup already, especially somebody who's using T models, where we run into issues was not in our model, but in the other models that we were importing. So if other model authors who have already done this setup, if they can provide help, that would be the best.
Thanks, Drew. If anybody wants to volunteer to help Drew, please reach out to him. Can we go to slide number 7, please? This is the enhanced VPN framework document. This has been around for some time. There hasn't been any new revision made to this since the last session. But the authors have indicated that this is about one editorial rev away from requesting working group last call. So please do give this document a thorough read and review it in anticipation of a working group last call in the coming weeks. Can we go to slide 8? This is the GMPLS controller interwork document. There hasn't been any changes to this document since the last session. From the status report of the last session, it doesn't seem like there are any open issues either. So the question that we have for the authors is, are there any pending items that you would like to take care of before this can be considered for working group last call? Is there any author in the room or remote who would care to chime in on this?
Yeah,
Yilin,
yeah, this
go
is
ahead.
Eileen. I think we finished most of the work for this contribution, and we are requesting the working group to review the document. Thank you.
Okay. Can we go to slide 10, please? This is the IETF network slices document. As you all know, this forms the basis for several of the documents that are currently being discussed in our working group. Adrian is saying that we are ready for last call. There have been several changes made to the document since the last session, so please do take your time, give it a thorough read, and review it in anticipation of a last call in the coming weeks. If you do have any more changes to propose, it's not too late. Please do take this opportunity, and I'm sure Adrian would be happy to comply. Um, can we go to slide 16, please? This is the T service mapping Yang document. Uh, in the report that Drew sent, there is a comment at the bottom which says that this is currently blocked by the SR policy Yang document. The SR policy Yang document, which was adopted in spring, hasn't been updated in a while. I think Drew did bring that up on the spring mailing list, and there was a response from Kamran, who holds the pen, that he would get to it soon. From the service mapping point of view, all you need is some sort of a reference to the underlay tunnel or the policy onto which the service is mapped. This could be a direct reference, so all you need is uh, a key for the policy, or it could be some sort of an indirect reference where you use color or some tag to do the mapping. So this should be a fairly straightforward dependency, and Drew, I'll work with you and Kamran in the next few weeks and get this sorted. This shouldn't take too long. Can we go to slide number 19, please? We took a couple of Yang documents to last call in recent weeks. We haven't closed on them yet. This is the first of the two. This is the path computation Yang document. There were several comments that were raised during last call. There's one revision containing the changes that for the items that have been addressed on the list that should go in this week, as I've been told. There are still a few pending items, and those should follow up in another revision shortly. The plan is to have a follow-up working group last call, maybe a short working group last call to give the working group um, uh, sufficient time to review the latest set of changes. Next slide. Actually, go to slide 23. This is the Yang T document. Again, this is in the same boat as the previous one. Rev 30 was published to address several comments that were raised during last call. There are still some pending items. The one sticky issue is with respect to management of identities. There were a couple of suggestions, more than one at least, where a suggestion was made to have IANA manage identities module. uh, this is turning out to be a bit complex. For certain scenarios, it's a bit impractical as well. So the authors are trying to figure out ways to address this. So once this item is resolved, there should be other revision coming out. And like with the last one, the expectation is that we'll have a short working group last call for the working group to review the latest set of changes. That's all we have in this slide deck. Any questions on any of the working group documents, not just the ones that I just covered? I don't see anybody rushing to the mic, so we can move on to the next slide. Italo, you're up.
Okay, hi. Can you hear me?
Yeah, we can. Can you change? I mean, you should be able to move the slide for yourself.
I'm looking for some control. I don't see any control to move the slide. 1 second. No, I don't have control for the slides.
Just keep going. I'll change.
Okay, okay. So I'm Italo Busi. From away, I'm presenting on behalf of co-authors this new draft proposing some updates to the ITFT types, which are defined in RSC 8776. Next slide, please. Okay, some background. Okay, what we needed, what we discussed was that we need to do some tiny update to the ITFT types YAM module, which has been already published in RSC 8776 to support some of the changes on the T-tunnel model or under documents, which are ready for working group last call. At this moment in time, what we need is just to define a new type def and a new grouping, not that much. And we were discussing during last meeting what is the best approach to move forward with such a small update. We had some issues with going for a complete RFCBs, and we got some suggestions which we follow, and we asked adoption. We got adoption, but we get some comments. We got some technical concern on the need for a common grouping that describe encoding and switching time, and different opinions were raised during the process approval. During the approval of the process, somebody was in favor of updating the RSC like we proposed in the draft. Others were more in favor of obsoleting the RSC 8776 and to go with a complete BIS. And the third option was also to define a new model, which just provided the additional elements. And in addition, we got there are a few post-working group adoption comments. One is to move some of the identities from the ITF T module into the T types. Is some of the proposal for addressing the working group last call comments on the ITF T YAM model. There was some comments from Chaude on the T topology identifier, and I received the comments from IANA. They did an early review and they agreed. They proposed some changes to the session. Next slide, please. Okay, the first issue is the technical comment on the encoding and switching types. The comment was basically, why do we need a common grouping, because we don't know whether we need to have a common definition for switching and encoding for all the TIS modules that will be developed in the future. The opinion is that, well, the pan computational RPC has a strong requirements to be aligned with the T-tunnel model. There were long, extensive discussion at the beginning of the work that everybody agreed on the importance of keeping alignment between the T-tunnel model and the pan computational RPC structure. We initially copied the definition from the encoding and switching type from the T-tunnel model and immediately went out of sync because there was a change done on the model. So the grouping in YANG has been defined to avoid this problem. This grouping is and is used by the computation.
Yeah.
The proposal is
Hello,
not
I think
change
you're
the
breaking up.
types, just to make it available to everybody if you need. Oh, can you hear me? Hello? Hello?
Hi, Italo. We're having a little trouble hearing you. If
Okay.
you can try repeating the last few sentences, I think we'll be okay.
Yeah, okay. Thank you. Okay, I say that the grouping, can you hear me now? Okay.
Yes.
Okay, the grouping is already defined, and the proposal is to move it in T types to make it available to anybody who needs to use it. My concern is that there is no major. If you keep the grouping as it is today, we are causing the problem to somebody in the future which may need to implement just this grouping and will need to implement the ITFT YAM module just to import the grouping. Moving the grouping here will not cause any additional trouble because it's not mandating people to use it. If you don't need the grouping, you don't need to use it, even if it is defined in the ITFT types. So we don't think that moving the grouping from the ITFT and the ITFT types is causing any harm, but it's just helping people if they need in the future. And the real issue that we see here is just that moving this definition from the ITF T module to ITFT test may delay the progress of the ITF T module but this is more a procedural rather than a technical issue. So the proposal is to keep the grouping if you are able to move forward this document in a timely fashion. If there are no comments, next slide. Okay, then there was a couple of comments from Chowdhury. One was about the fact that at this moment in time, in the topology model, we have a different set of identifiers in the net for networks, node links, and termination points in the network topology and in the AT topology. For example, the node ID is defined in the network topology as a URI. The AT node ID is defined as a dotted code. And there are some issues in some deployments where people would like to use the node ID. So the proposal is to update the T types to make it a union between URI and the existing type. For example, the T node ID can be defined as a union between the dotted code and the URI. Another second email that was sent by Chowdhury is some concerns on the definition of the TTP identifier as a binary. And again, the proposal here was to make the TTP identifier as a union between binary and the URI. I think this proposal requires some discussion, but of course, they may broaden the scope of the update. So we need to discuss and see how to deal with those comments. I don't know. And next slide.
You have a couple of people
Okay.
in queue. I'd
Maybe,
ask them
yeah.
just to go keep it short. So Tarek.
About this, hi, this is Tarek. My question is about the union. I realize that you haven't discussed thoroughly this, so but are we going to allow a mix of nodes to be identified by different ways? One is URI, one is dotted quad, and in the same topology. That's one thing. And the other thing is, do we rely on parsing the value to know that this is a dotted quad or this is a URI? It becomes error prone, something like that. But we can discuss that. I realize that you want to still
Yeah, absolutely. This is something to discuss in the context of this document. Yeah. Good question. Okay, the last point is about the procedural. Okay, we had discussed some of options and issue in the version 01 of the document, and unfortunately, we removed it from the document that was pulled out from working group adoption. But we got a comment from Drew about that would be good to put some justification maybe in appendix, since it is the first time we are doing such an attempt, and maybe I tend to agree with him. Maybe what we can do, we can bring in if you agree to follow the update approach, maybe we can put in the appendix some text that describe the rationale for the proposal. The key question that I found from the discussion on this procedural issue is whether we think as a group that we need to have a lightweight approach for updating and publishing YAM models. Because I think this is the key issue. The content that we are putting into this document up to today is something which is quite mature because it's coming from working group documents, some of which are in working group plus call. We are just moving them into a new document, but if we go with a BIS of a 90 pages document where everybody reviews page by page and word by word, I don't think the approval process will be that fast. So I think the key question here is whether we want to have such a lightweight approach or not. I see someone in the queue. I cannot hear.
Yep,
Okay.
I had to turn the mic on. Yeah, so John Scudder here. About the BIS where everybody reviews line by line and word by word. One thing that the IESG are trying to do is for BISs with sort of well-contained small change sets is to only review the well-contained small changes and not take it as an opportunity to do a open season on reviewing the whole entire document and reopening past issues. So we can discuss further offline, but I would encourage you, for documents that have small change sets, if you're trying to decide what to do, please talk to me before deciding that it's just not a good option.
Okay.
Thanks.
So your suggestion is the BIS can be a valuable approach, and we can address the BIS in such a way that the review is only limited to the changes. Okay.
Yeah, that's
yeah.
my
Okay.
suggestion. Again, we can talk further offline. if you
Okay.
like.
Yeah.
Yeah, we're pretty much out of time, but I'd like to close on this issue. So if you can get to that final slide.
I think
with
this slide, I think the suggestion from John will solve all this issue. Yes, because that will be looks a reasonable approach. Yeah. Okay. I think you can skip the next slide, Lou. No, I think we can follow up the suggestion from John. Looks like a good a good solution. Okay, so the next steps is to move forward with addressing the technical and procedural comments, and then we need to align the working group, which are using these new types. I think that we have at least the T path computation layer 3T topology model. And then we can try to go as quickly as possible to working group last call to avoid blocking the progress of those depending working groups. Of course, we need to clean up the procedural approach. Thank you.
Yeah, we see no reason not to progress this to last call very quickly as soon as you get the document issues cleaned up. So if you rev the document and say it's ready for last call, expect us to follow through with that
Okay,
pretty
thank
quickly.
you.
Thank you.
Okay. Yep.
Hello, it's you again.
Okay. The next draft is about the applicability of CTN to packet optic integration. I'm presenting on behalf of authors and co-authors again. Next slide. Okay, a quick recap. Okay, this document is analyzing the applicability of the IETF YAM models between the MDSC and the optical and packet PNCs to support the packet optic integration in case of multi-domain packet and multi-domain optical network. The use cases that have been analyzed are inventory, service, and topology discovery, in particular the link between the routers and the ROADMs, and the discovery of all the optical and packet paths, and how it is possible to establish layer 2 and layer 3 VPN, which traffic engineering requirements that can drive the setup of new optical path. And next slide. What has been changed? Okay, we did some updates. We have generalized the description of the SRT path discovery setup of update. This was a comment we received during the latest IETF presentation, and we discussed that on the mailing list. So we made a description generic and applicable to any technology for which the T-tunnel model can be used at the MPI above the packet controller. These with MPLST and SRT are just examples of such technology-specific augmentations that can be provided to support this technology. The text has been reviewed, and the description for SRT is also generic enough to cover both SR-MPLS and SRv6 options. We think that instead the interdomain option of BGP-LU is considered outside the scope because in that case, the T-tunnel model seems not applicable, and the solution is slightly different, and we decided not to go into too many options to analyze into the draft. If interesting, we can set up a new draft if there is a need for analysis. An additional change that we did on this revision is we added the analysis for the lag link aggregation. So how to discover and set up and update the lag in case of intra-domain links. So links between two routers in the same domain with some optical path underneath of it. We didn't discuss analyze the inter-domain lag because in this case there is no multi-layer coordination, so it's not of interest of a multi-layer analysis. We found that the LLDP configuration has some implication when used with lag, and we analyzed that we need to make sure that the LLDP properly configured to allow the ROADM snooping to work properly. And we have also to update the link setup update procedure. and few minor text update. Next slide, please. It is more in detail on the change. Oh, it's not coming. Okay, this about the, oh, okay. Okay, one was about the LLDP, the previous slide. I think you moved 2 slides ahead. Okay, yeah. This one we noticed that, for example, if you enable LLDP on the lag, you can enable LLDP on both the lag members and the lag group. So there will be some links where you send 2 type of LLDP packets, one for the member and one for the group. And this will, but the cross-layer discovery should be based only on the LLDP, so the red and the blue, for the red and the black in the example of the slides. What you notice that in order to make the interdomain link discovery properly work, the LLDP snooping should work on the black LLDP packet, so the one sent on the lag members. And there are 2 suggestions in the draft. The suggestion in the draft is to disable the lag on the aggregated ports, so the red LLDP packets will not be generated by the router, not seen by the RODAM, and everything will work in the discovery as if there is no lag. There are other mechanisms we found. For example, in the standard, there is a definition of the link aggregation TLV that may be used, but some care has to be taken to make sure that the router and the RODAM, of course, supports those options, because in this case, you need to be able to distinguish on the RODAM side which LLDP packet belongs to which session, and use only the black LLDP packets for the discovery. Next slide, please. And the multi-domain, interdomain, the procedure has been slightly updated because the first steps are the same. So in order to set up an IP link over optical, you have to create an optical tunnel in the optical network. You have to create an Ethernet client signal, which allow to steer the traffic from the access internet link over the optical tunnel. As soon as you create this configuration in the optical domain, you have an Ethernet link between the 2 routers, which this link can be either discovered by the packet PNC, if there is some mechanism like LLDP or proprietary mechanism, or if this mechanism is missing, it can be configured by the MDSC. In the previous version, without lag, the configuration or the discovery of this link was sufficient to trigger the configuration of the IP link over it. But now, with the lag, the packet PNC doesn't know whether this link has been created to become an IP link or to become a member of a lag. So we change a bit the procedure to enable the MDSC to explicitly tell this to the PNC, and we consider leverage the fact that the IP topology is rewrite, so the MDSC can create the link between the routers over this Ethernet link, and this will trigger the packet PNC to configure it. The configuration of the link is still done by the packet PNC, but the trigger is now the creation of the link in the IP topology by the MDSC. If there is the lag, there will be a different procedure to add the link to the lag. Next slide, please. Okay, now we have some open issues. We are tracking them on GitHub. Most of them is just requiring people to write the text. So we have no really outstanding issue that requires a lot of discussion. The only question that was raised recently is whether there is a need to add some examples for API calls or workflows. For example, some JSON encoding. This can be useful if you want to analyze the details of the YAM models, but on the contrary, will increase the weight and the size of the document. So we are not sure whether making this change is a good idea or not from the document. So we are looking for feedback from the working group. And there is some needed to continue working with Screen. Oscar is taking care of it. To discuss some of the technology-specific augmentation for SRT to the T tunnel model. Thank you.
Any questions? So, Italo, in the last meeting, there were several comments about the use of SR-specific examples in this model. The guidance given at that point was to describe the procedures in a technology agnostic manner, and then bring in SR specific examples or RSVP specific examples wherever there's a deviation. I do see that there has been a conscious effort to address some of that, but it's nowhere near done. At least that's my opinion, and I believe my co-author is also my co-chair is also agreeing with me on that. So that's something that you would have to keep addressing as the document evolves.
Okay. Okay, okay, maybe we can talk offline. I think we tried to generalize it. Maybe something has been oversight. Okay. Thank you.
Thanks. Reza?
Hello, everyone. My name is Reza Rukui from Siena. On behalf of my co-authors and contributors, I'm going to present the network slice NBI Yang model. Next, please. The changes in the latest revision is outlined here. I'm not going to cover, all the bullets here. It's self-explanatory, but overall, we align the STP connectivity construct that we have attachment in the Yang model with the draft, with the framework. We try to be aligned with everything that we have on the framework. We also included some of the reusing of the common model that we have, VPN and so forth. We also aligned some of the choice for the Yang model in the for the various connectivity, the services that we have, point-to-point, point-to-multipoint, and any-to-any. These are all the types that define in the framework. So, and we put lots of examples. Thanks to John, he provided the lots of examples that clarifies what the model is and how we are going to use it. And there are some other aspects about the DSCP and match, and we try to, add more clarity to the Yang model. The last bullet, we remove 5G example that we have because we have another draft. I'm going to present it shortly about application of the NBI and generally IETF network slice in 5G. From that reason, we remove it from here and we add it there. Now, there are few issues that I'm going to discuss. There are open issues that we have. And if we go to the next slide, in general, to just have the baseline here, we put 6 different IETF network slices in this picture, network slice 1 all the way to 6, with the various connectivity that we can have. We can have point-to-point, point-to-multipoint, any-to-any, and we put those examples here just to have a baseline and clarity that generally speaking, the connectivity construct has one direction, which is specific SLO. It can belong to a group, connectivity group. So a group has multiple connection, potentially with the different SLO. And this is the idea that we go after. Again, this is aligned with the framework document that we are based. If you go to the next slide, the first issue that we are going to, this open issue is about the policy, SLO, SLE policy. As you see in the model, at the beginning of the model, we have the policy. This policy is defined in the 3 different areas, at the network slice layer, at the group layer, and the connection layer. The question here is, do we need to have an ability to, first of all, configure this policy as a model, or this should be part of, it should be outside of the model? So this is one aspect. And another aspect is so-called inheritance and update. If, for example, we want to create a IETF network slice with a well-known gold policy, and somebody says, oh, I want that gold policy, but by the way, I want to just change one attribute of that. should we allow that? How we should do it? Do we rewrite everything, or do we specify that a specific attribute that inheritance and update comes from that? So basically, the first issue is policy related, creation of the policy, update, and inheritance, and this is still under discussion. That we have a weekly meeting about this one, and more than happy to hear everybody's idea about this one and what's the best way to handle it. Next, please. The second one is right now at the match criteria that we have, we are specifying match and value. And the question is, if we want to have the complex combination of the IP header for the match, should we allow this or not? And if we want to do it, is this reasonable to use ACL type of the reference here? And there is a pros and cons, obviously, but this is an open issue that adding that ACL might help here. But again, we need everybody's opinion about that one. If you go to the third issue that we have, the summary of this one is, if you go take a look at the bottom left picture, we have STP today, STP peering, which has two areas, protocol and OPEC. Generally speaking, the idea here is we want to be, quote unquote, technology agnostic. From that aspect, we define a group of attribute types and value. From that aspect, we didn't try to, two examples is in the middle picture, for example, for the static routing or BGP, but we, on purpose, we didn't put that one in the protocol because that idea of the technology agnostic is not there anymore. From that aspect, we have a generic concept of attribute and value. And also we added an OPEC, which adds more flexibility. The issue is on the top right, if for the interoperability issues, if we have these two, the Yang could have some interoperability, and we need some proposal and the feedback from the Yang doctors and working group to see what is the best way to handle it, what is the balance to put something specific, but at the same time, we keep the idea of the technology agnostic idea here. And this is just, I bring it up to make sure we are all aware of that. And if there is any proposal, and I'm sure this is not the first time it happened, but if there is any proposal how to fix this one, we'd be more than happy to take that.
Yeah, in other models, I don't remember off the top of my head which, but I can find it. What we've done is added a, I believe it was a choice. Actually, it doesn't matter the specifics. We added a place where for future augmentation, for technology-specific augmentation. So rather than putting an opaque value, you put a place. I think it was a choice statement.
Do you have
Well,
example?
yeah, I'll
which
find-
Yang
I'll-
model?
I'll-
If you
yeah,
can
yeah, I'll
send it
find
to
it.
us, it would be great.
Yeah.
Thank you. If we go to the fourth issue, there was some discussion about adding to the model, as in the idea, some type of the topology of the network. This is quote unquote similar to the V2 type 2 VN that is specified is ACTN. There was some discussion that it might be needed, but the general question that we have, is this something that we want to do? Because again, we don't want to remove that technology agnostic concept from the model. And the question is, do we need to do that one? And if the answer is yes, we have to do that one, we can add some type of the similar type 2 VN in the model, but at this point, we want to make sure the question is, do we need it, yes or no? And if the answer is yes, we are going to continue going forward. And I think the last slide is going to give us, okay, there was, is this, okay, I thought there's 5 issues, there are 4 of them. So at this point, we are going to resolve the open issue that we have, and if there is any further comment, more than happy to hear that. Any question, comment, please? Thank you very much.
Regarding the issue 4, I think it's useful. I think it's useful to let the client know what abstract topology is available before the service is being made. I know this ask has been around for a while. I think even before we adopted, there were some examples for it, and it keeps coming back. So I think it is it should be discussed and added if you can. There are existing ways of representing the customized topology and sharing it with the client. You could leverage those, and then in the service request, you can just reference that. But that's something that I would recommend you to look at.
Okay, maybe I will talk to you. Thank you for the comment. Thanks again.
Tarek?
Hi. I'll rely on you for flipping the slides.
Yeah, I had a network bounce. If it happens again, just take over.
Okay, thank you. My name is Tarek Saad, and I'm going to give an update on this draft Yang data model for network resource partition policy. We have presented this draft multiple times in the past, and this is just going to concentrate on the changes introduced in this revision. Next slide, please.
You should have control.
Okay. Thank you. So a bit of introduction before we talk about the changes. Network resource partition, the definition of it was introduced in IETF network slices draft. It's a collection of resources identified in the underlay network to support the IETF network slice service. The NRP policy was introduced in IETFT's NS-IPMPLS draft, and is a policy construct that enables instantiation of mechanisms in support of service-specific control and data plane behaviors on select topological elements associated with the NRP. The draft defines a Yang data model for the management of NRP policies on an NRP capable nodes and controllers in an IP-MPLS network. There were multiple modes identified for NRP, for network resource partitions in the network. One was partitioning in the control plane, another one in the data plane, and the third mode was when partitioning is happening in both control plane and data plane. This Yang data model will cover all three flavors. The changes introduced in this revision is a target node that is state only, that describes the filtered topology. The filtered topology is also described in the draft IETF network slices, and we will talk a little bit more about it in slide 9. So under topology container, we have a list of filters. There are multiple variants of filters that are defined in another draft. I have a reference there. The topological elements that match such membership criteria, the filters can be used for different purposes. One is overriding reservations on select elements, but there are multiple variants of filters that one can use. And as a result of filters, there will be network elements that match the filter. And the set of network elements or topological network elements that match the filter will be displayed under filtered topology. We have two choices of ways to describe this filtered topology. One is just a reference to a topology that we create for the network topology elements that matched the filter. The other is to just reference the topological elements in the native topology as they are. We just have pointers to them. And the latter, we just have two references. One is the network reference of the physical topology, for example, and the topological element key, node or link. So these are the two flavors of ways of presenting the filtered topology. In terms of next steps, we have engaged with authors of draft WDTs and RP Yang. We believe it has some resemblance, and we are working with them and finding ways to collaborate with them. So we look forward to continue this collaboration. And the second next step item we have is to add some tree instances of the data model in JSON, for examples on network controller and on the device. And as usual, we welcome requests, we welcome reviews from the working group, and as well as any feedback.
We have Adrian in the queue.
Hi there, this is Adrian. Thank you for continuing on this document. I'm a little unclear about your mode B, which is the control plane only. Is what you're saying there that there's actually the partitioning is happening in a logical way in a central controller? So it's the data plane is unaware of the partitioning, but it's happening in some accounting mechanism in a central controller.
Hi, Adrian. Thanks for the question. What we mean by control plane only is that the reservations are, or the bandwidth bookkeeping is being done either on the controller or on the network element vis-a-vis RSVP way. So the call admission module is sitting on the node or on the controller, indeed. It's possible. But the idea of that reservations are managed and maintained maybe by priority order on that reservation manager, and not in the data.
Okay, yeah, I think I get that. Maybe a few more words in the draft to help people like me.
Okay, sure thing. Thank you.
Okay, I don't see anybody else in the queue. Thanks, Tarek.
We have Bo.
Okay, I just see Bo. Yeah, thanks. Bo, go ahead.
Oh, she's presenting. Oh,
Okay, I think, yeah, Bo is presenting next. Thanks, Tarek.
oh, thank you. Thank you so much.
Oh.
Bye.
Hello, everyone. This is Bo, and this NLP Young module has been presented for several times. So this time, I'm going to give some updates on this draft. Next, please.
I think you have slide control. At least I don't anymore.
Okay. Okay, thanks. Yeah, I can control. And in this version, we add a section to describe we give some summarize on the NLP modeling requirements.
Bo, you're breaking up pretty bad. Bo, we are not able to hear you.
Bo, your audio seems not to be working. I think maybe we will skip Bo and then come back when hopefully if you could do an audio test, that would be appreciated. My session keeps dropping locally, so I don't know if others are having that problem also. So I don't know if it's a Meet Echo problem or something else, but we'll try to keep going. So Bo, we'll come back to you at the end. So we're going to move over to Jay. Or G.
Okay. Can you hear me?
We can, G. Give us a minute. Yeah.
Okay.
So you have 10 minutes for both these documents.
And you should have control.
So, yeah, good. Actually, I combine this end-to-end network slice with a hierarchical network slice. The two drafts will be presented together here. I'm going to present this update of these two drafts and some considerations on behalf of the co-authors.
Jimmy, can you be a bit louder?
How about now? Can you hear me?
Yeah, I think that helps.
How about now? Okay. So here are some background about this work. We know that network slicing can be used to meet the connectivity and SLO or SLE requirements of different service and customers in the shared network. The concept network slicing was firstly defined in the 3GPP, but they only cover the RAN and the mobile core network slice subnets. And for the transport part of the end-to-end network slice, IETF network slice is going to be used to provide end-to-end slicing and the performance guarantee. In the IETF network slice framework draft, it describes the concept and the general framework of the IETF network slice. And it also mentioned that the network slices can be realized by mapping one of a group of the connectivity constructs to an NRP. Usually, an IETF network slice can cover either a single domain or multiple domains. And the IETF network slice may be further sliced to provide fine granular connectivities and the resources for the hierarchical customers or services. This kind of multi-domain slice or the hierarchical slice scenarios are briefly mentioned in the IETF network slice framework draft. And we think it is useful to elaborate on these scenarios and also the realization considerations for these multi-domain and hierarchical slice cases. So here is a typical IETF end-to-end IETF network slice scenario. This is using the 5G network slice as the example. In the transport network segment, one or multiple 5G network slices can be mapped to an IETF network slice, and this realization could be an enhanced VPN service. Then in the underlay network, the IETF network slices can be mapped to, can be supported by a multi-domain NRP, which is achieved by concatenation of multiple intra-domain NRPs. This mechanism is also similar to the inter-domain VPN cases. So as shown in this picture, we can have 3 TN transport network domains, and each domain can have one or multiple NRPs provided, and the concatenation of the different intra-domain NRPs in the domains provide a multi-domain NRP to support the end-to-end IETF network slice service. So here, in most of this end-to-end network slicing realization is about how to provide the concatenation of the NRPs. Firstly, I think a network controller will be needed for the creation and the concatenation of the multiple intra-domain NRPs to provide end-to-end network slice service. And secondly, the ingress node of the NRP will need to steer the IETF network slice traffic into this multi-domain NRP. Then the information of this multi-domain NRP will need to be carried in the packet for the mapping of the slice service to the corresponding intra-domain NRPs at the domain border node. Such information can be carried as either as an end-to-end NRP identifier, or it can be carried as a list of the identifiers of the intra-domain NRPs to be traversed by the packet. Regarding the detailed encapsulation
Jimmy
of
has
this,
someone in the queue. Jimmy, do you want to take questions now?
Let me take a look.
John?
Okay, maybe you can ask.
Yeah, hi, John Malooly, Cisco. Back on the previous picture, you're concatenating NRPs, where shouldn't we really be concatenating IETF network slices per transport domain? I mean, that would be a more modular cookie cutter approach than trying to do this at the NRP level. Plus, you might have different policies between different networks. So just asking about how the problem is being tackled in this case.
Yeah, I think that's a good question. I think what you mentioned, it can be considered as the inter-domain option A, so that we have a different network slice endpoints at the domain border nodes, so that we can concatenate actually the network slice services end-to-end. That is also an option.
Okay, so just it's something maybe you should consider, and then maybe at the hierarchical level, it's more of a controller problem in terms of how to manage the connections between the different slices. Thank you.
Yeah, I agree. That scenario can also be covered in the future versions. But here we are mostly talking about the concatenation of the NRPs to build an end-to-end slice service. Thank you. Okay, let me continue. So the encapsulation of the multi-domain NRP information with different data plane are specified in the following documents, and I will not go into the details of these encapsulations. Please go and read this draft and give feedback. Thank you. And the next following slides are about the hierarchical network slice cases. This page, we list several use cases of the hierarchical network slicing, which means we can have the first level of network slice, then have a final granular network slice created within the first level of network slices, and we may have more hierarchies based on this model. In this hierarchical network slice draft, we may describe some considerations about the realization of the hierarchical network slice in different network planes, including the forwarding plane, the data plane, the management plane, the control plane. For the forwarding plane, it is mainly about how to partition the resource hierarchically and how to represent the hierarchical partitioned resource to the network link, like at the link level. So we have different options to represent the hierarchical resources. This we have different impacts to the control plane and management plane. The details are described in the draft. And for the data plane, the major issues are how to identify the hierarchical network NRPs, and we need some identifier which can be used to identify both the first level of NRP and also the hierarchical levels NRPs within the first level NRP. We have also several options of this NRP identifier in the data plane. Like we can use a unified identifier for different levels of NRPs, or we can have a hierarchical identifiers to identify the different levels with a different segment of the identifier. This will also have different impacts to the data plane encapsulations. For the control plane, I think the challenge is we need to use control plane to distribute the attributes of different levels of the hierarchical NRPs, both among the network nodes and also to the controller. And with the number of the hierarchical network slices increases, the control plane optimization would need to be considered. As for the management plane, needs to provide the independent lifecycle management for different level of the NRPs and the network slices. Also, it will need to consider and maintain the relationship and the constraints between the different levels of the NRPs, so that the resource allocation or some other constraints will need to be considered when to create a hierarchical NRP within the base NRP.
If you could wrap up, that'd be great. Oh,
yeah, this is the last page. So here, the next steps, we think the end-to-end and the hierarchical network slices can be considered as advanced application of the IETF network slice, while the maturity of these two topics are not the same as the contents in the base IETF network slice framework draft. And there was concerns raised about whether they can be a standalone draft because they're not very large draft document. Here we have a question to the working group. Should we consider to merge these two drafts, the end-to-end and the hierarchical slice drafts, into one document, or do we keep them separate as is? We would like to welcome further comments and feedback so that we can update the drafts accordingly. That's all.
So in the context of the first draft, in the last meeting, we had said it would be best to see if you could merge the text with existing documents. For example, some of the text clearly could go to the framework. It's not too late to get text into the framework. It's much better to get it into an existing document, particularly one that's about to go out the door, than to have standalone documents that we have to run the process on. So for both of these documents, if there's an opportunity to take the text and put it into another document, please do so, and preferably a existing working group document. And the best way to do that is send the text to the list, talk to the authors. I think some of them you may be a co-author on already. So talk to yourself. Please get the text into the existing documents if you can. Thank you.
Yeah, that is a good feedback, and we would like to welcome further feedback from the working group on this step. Thank you.
Leon?
Hi, everyone. Can you hear me?
Loud and clear.
Okay, thank you. Do I have the control of the slides?
Yes, you should have control. Please go on.
Okay, thank you. Hello, everyone. This is Li Yan coming from China Mobile. I'm glad to do the presentation on behalf of all the co-authors. The topic is about the segment routing-based solution for hierarchical IETF network slices. First, just as mentioned just now by previous presentation, the concept of the hierarchical IETF network slices is based on the IETF terminologies: network slicing, IETF network slice, and network resource partition. The hierarchical IETF network slices describe the network slices which can be further sliced or combined hierarchically. For example, one of the possible scenarios is that an industry slice needs to be divided into multiple customer slices. This draft proposes a two-level hierarchical IETF network slice solutions, which is based on the segment routing. Generally speaking, the level 1 network slice is realized by associating flex elbow with dedicated sub-interfaces. And the level 2 network slice is realized by using SR policy with additional NRP ID on data plane. Sorry, it's a bit slow. And this slide shows the framework of the two-level hierarchical slices. The level 1 is associated with the flex algo, and the traffic is steered into the flex algo passes using the prefixes or SR radio locators. And the level 2 is associated with one or a group of SR policies under the level 1 NRP. And the traffic of the level 2 network is steered into the SR policies. Based on the framework described above, the network resource is also partitioned in a hierarchical manner. Taking the bandwidth resources as an example, the level 1 bandwidth is guaranteed by a layer 3 sub-interface with dedicated bandwidth. And the prefix seed or SRv6 locators is used as the data plane identifier. And the level 2 bandwidth is guaranteed by queues with dedicated bandwidth under the layer 3 sub-interface. And the NRP ID is used as the data plane identifier. This slide shows the relationship about the NRP and the slice. Actually, each NRP, either level 1 or level 2, both can be used to support one or a group of network slices. This is consistent with the IETF definition. But for actual deployment, I think it's much more complicated for level 2 NRP to be mapped to multi-slices, and it makes little sense since the resources of the level 2 is already finely divided. So here, the level 2 NRP to slice is shown as 1-to-1. Also, we think if there is the requirement scenario that this can also be 1-to-multiple. This is one example for the whole solution. For the picture from the bottom up, the physical network is divided into 2 NRPs through the flex algo, and each NRP is mapped to one slice. One is for the education slice, and the other is for the healthcare slice. For education slice, there are 2 customers, for example, University 1 and University 2. They all have different access points and interconnection. For healthcare slice, the second slice, there is only one customer. Based on the topology above, the resource partition is like this. Taking PE1 as an example, the physical interface 1, there will be 2 sub-interfaces, and under which there will be 2 or 1 queue respectively. For physical interface 2, there will be only 1 sub-interface and 1 queue under the sub-interface. And all the sub-interfaces and the queues are associated with the dedicated bandwidth. The last picture illustrates the traffic forwarding. From the picture, we can see that the final result is that for the normal education traffic, for the first slice, the packet is encapsulated by the destination of end state associated with the specific flex algo, and the traffic is forwarded through the layer 3 subinterface. And for the specific traffic coming from University 1 to University 2, the encapsulation except the IPv6 header and SRH also includes the additional NRP ID, and the traffic is forwarded through the queue under the sub interface. Okay, this is all for the solution. We sincerely hope to get your feedback to improve our solution. Thank you very much.
Thank you. Any comments? Then we'll move on.
One quick comment. So irrespective of where the text from G in the previous presentation goes, this I believe should go to the Spring. You can probably present it there and see where it takes you.
Okay,
Robin,
thank you for your suggestion. If necessary, we will present it in Spring also. And we also looking forward for the feedback in TIS. Thank you very much.
Thanks. Yeah. Thank you. Robin, you're next.
Okay. Can you hear me?
The
Hello?
update that you just made should have been reflected, but yeah, in case it doesn't show up, continue with what you see on the slide. You should have control.
Okay. Hello, everyone. This is Zhenbin from Huawei. Today, I will do the presentation about the consideration on generalized IETF network slicing. Okay, here this brief background because we know we have this draft to describe the concept and the general framework of IETF network slice. But now with the development and the deployment of IETF network slice in different types of network for different applications, there are emerging requirements about the new capability and the functionality of IETF network slice. It's expected that the concept IETF network slice and the network resource partition will be generalized. This document describes the consideration about the possible generalization of IETF network slice and the network resource partition. Okay, so here this is the description of the relation between the NRP and the topology. Because we know that the NRP needs to be associated with the network topology to determine the set of network resource of the NRP. So in the data plane, the NRP specific identifier could be used to determine the topology and the resource of the NRP for packet processing. But we know now that we have this one draft proposed in 6-man working group. That's the draft to describe how to use the IPv6 to carry the multiple topology ID for the IGP multi-topology or the IGP flex algo. because this is to cope with the use cases that the same forwarding addresses could be reused for packet in different topology. That means that because we know that for the different multi-topology, we can have the different forwarding address, but we also have the use cases, but we use the same forwarding address, but we use the topology topology ID to identify the address to be used for the different topology. So if we use this solution, so that the NRP ID may be generalized to identify both the topology and the set of resource. So here there has this the first question: what should be the relation between the IETF network slice and the multiple topology and the flexible? I mean, they should be independent, or that means this is the multi-topology should be the special case of the NRP. So that's the first issue. The second one, I mean, the NRP is allocated with a set of forwarding plane network resource to guarantee the SLA. That means all SLO, etc. But now, because as the development of the NRP, so the scope of the NRP resource may be extended to cover other types of resource. Here give this the several examples. The first, the resources need to be provided guaranteed latency for DataNet service. All this the resource can be used for some network function of the NRP. For example, the security functions. And also this the resource can be the virtualized resource. Maybe that's the virtualized device to support the IETF network slice. So here we have the two questions. The first one, what should be the relation between the DataNet and the IETF network slice? And this is another question. Can other services such as the security can also be seen as the IETF network slice or the NRP? So means that the network slice not only used to guarantee the SLO, but also used for other services such as the security. So here we also have the NRP for multiple connective constructs. So here we give the example for the virtual list line service. So we can say that the virtual list line can be mapped to the NRP. So it can be one-to-one. It can also to map shared the NRP. But here we give the example because here we can see that's a two list line which needs the 2 gigabit the bandwidth respectively. But if one outgoing interface are shared by the two virtual list line, so that's the question: what bandwidth should be for the NRP? So I mean, so here this is 2 gigabit, or that is 4 gigabit, or this maybe other gigabit for the virtual list line mapping to the NRP. So I here this is what should be the NRP for the virtual list line. And here this is the last this generalization of the IETF network slicing, because we know at the beginning this IETF network slice is used for the 5G end-to-end network slice, but later this IETF network slice has been extended to the operators, the metro and the backbone networks. But now, as the deployment of IETF network slice, it can be extended for the campus network and the data center networks. So, and also maybe also the SD-WAN. But we know that for the operators, the MPRs or the SRMPRs or SRv6 as the tunnel. But you know, for the data center, I finished this one. Just the last page. Okay. So here, this also this the this means that the IETF network slice may be also used for the various the IP tunnels. besides the MPRs and the SRv6 tunnels, I mean the VXLAN or the GRE. So here we have this the generic IPv6 tunnel work that's for the network slicing used for other tunnels. Okay, so here this is the question. So we would like to solicit the feedback and also try to reach the consensus and revise this document accordingly. Okay, please, question.
Louis?
Can you hear me? Yeah. This is Louis Jalil. So I'm noticing that you, for some reason, it's more, the way you're presenting is more static resources and dedicated resources. You know, you keep looking for, I know we're allocating partitions, all this other stuff, but it looks like it's more static and hardened than being more dynamic. That's what I'm seeing just overall from your slides. Is that correct, or do you see it differently?
I'm not sure if I catch your the point very well, but here this just this some this the issues about means maybe the NRP the resource is not the bandwidth resource for the SRA, but it can be used for the topology, represent topology, or maybe the security service, etc. Yeah.
Thanks, Robin. Same comment as
Okay.
the one that was made for GE documents. I mean, see if you can propose some text to the network slices document, and for the underlay constructs for NRP in particular, you may want to consider proposing text to the NSIP MPLS document.
Okay, thanks.
Good morning again. This is Reza Rukui from Siena on behalf of my co-authors. I'm going to present application of IETF network slice in 5G network slice. Next slide. Just a quick background. If you are looking at the picture on the right-hand side, this taken from the framework document. There are various applications or use cases for IETF network slice. There are clearly mentioned in the framework document. You can use the concept of IETF network slice to, for example, do the connectivity in data centers or the wholesales and so on. These are various use cases. The one that we are referring here is a 5G. Obviously, 5G network slicing is one of the top runner at this time for the IETF network slice. And the goal of this draft is basically address the red portion on that picture. Currently, there are 3 drafts which are talking about various application of the network slicing in the context of 5G. You will see these 3 drafts, a different area of that is discussed. As in the previous IETF, the chair asked if we can combine all those drafts and have a new draft. So basically, today's discussion is combination of 3 drafts in a single draft to address various applicability and use cases of IETF network slice as a general concept or solution. In very specific use case is 5G. So having that in mind, if we go to the next slide, it shows the what has been done. At the very top layer, very higher layer, we merge 3 documents. We just don't merge them, but we add new content to it as well. So we consider some of the progresses that happening on the 3GPP 541, which is the management of the network modeling. We also added a use case for that, an example for that. And keep in mind that this document is still in progress, but the overall is we are basically merging those 3 documents as a whole. And if you go to the next slide, it shows the skeleton of the brand new document. We started at the beginning, and there is no need for me to go through each item one by one, but suffice to say that we already cover, as an author of those 3 drafts, we cover chapter 1, 2, 3. We went through that as a one cycle of the revision. We are still doing it other chapters, and we are today I'm going through this chapter to show the overall structure of the document, and we seeking advice and contribution from everyone. So if you go to the next slide, starting from the beginning, this is simply the framework. If you're looking at the picture on the right-hand side, we have RAN, radio access network. We have an access network, and we have a CN, core network, which are dedicated to the 5G functionality. There are various connectivity happen inside the RAN, inside the core, or between them. Those red area that you see is connectivity. And as you see, 5G network slicing, it addressing the connectivity. From that aspect, the use case that we have here is there are TN transport network connecting various component network function in different areas. And the role of the IETF network slice is how we can address that. For an example, if you go to the next slide, it shows a second level of detail for the examples. Depends on the RAN deployment. When we talk about RAN deployment, there are 3 RAN deployment in general: distributed RAN, centralized RAN, and cloud RAN. Without going through the detail of that, the difference is how the component of the radio access network are connected together. Everything is one network, the one component we have, or we are separating that one into the so-called centralized unit or the distributed unit. And this is a CU and DU. I'm sure you heard about this acronym few times. But the idea here is, this picture, you can go through the draft to see the detail. But the idea here is one single IETF, one single 5G network slice, depends on the RAN deployment, can have multiple IETF network slices. In other words, there are different connectivity which is needed. If you go to the picture at the bottom, for example, which is showing the cloud RAN, there are components, radio unit, DU, CU, and core, and there are different connectivity. That INS_1 or 2 and so on, it shows the multiplicity. And the idea here is a single end-to-end network slice from 5G perspective might have multiple IETF network slices. And this is the idea of the whole this picture. You can go through the detail in the draft to see more. So I'm running out of time. I have to hurry up a bit. Next slide. This one shows from the left picture to the right. We have IETF network slice controller.
Move to your open issues questions.
Okay, yeah, sure. So open issues here is first about the terminology that we use here. In a specific, should we use 5G end-to-end network slice, or we remove that end-to-end? Because from the perspective of the 3GPP, when they talk about network slice, inherently they're talking about 5G and they are talking about end-to-end. They never talk about these two explicitly. So the first question is, should we use or should we keep end-to-end? The next one is, should we use access network or in a specific radio access network? So because again, from the mobility is radio access. So we feel that for this question should be radio access network, but we are open to any question. Since you go to 3GPP document, you will see AN. You don't see radio AN, radio access network. Next slide. Next, to address these questions, and basically we are open to any suggestions, any comments, and the more collaboration is needed from that aspect as well. Louis, please.
Yes, in queue, we have Julian.
Go ahead, Juan.
So first, thank you for providing the combined draft. I have one comment and two questions. The comment is about the open issues, which term to use, 5G network slice or 5G network or 5G end-to-end network slice. My proposal is to use 5G network slice. So the first point is about 3GPP has no 5G end-to-end network slice. And end-to-end network slice scope is out of 3GPP because the connection between UPF to DN is out of the 3GPP network slice scope. And the third point is about BBFTR 522 use 5G network slice. We also discussed this question, to use 5G end-to-end network slice or 5G network slice. Our agreements is to use 5G network slice. So my proposal is to use this term to keep the term consistent. Okay, my two questions. One is about the scope for this document. I noticed that the scope for this document includes, the IETF network slice can result in ANCN and TN, and also about the IETF network slice deployment. I noticed that this is overlap with BBFTR 522. So my proposal is that if IETF want to do this work, my proposal is that IETF to send liaison to BBF. Okay, and my second question is about the solution. The mapping.
Excuse me, can you take your
you
questions
provide
to the list?
the mapping solution to realize the transport slice connected with.
So if you don't mind taking the rest of the questions to the list, we're running over time, and we have a couple of other people who want to ask questions.
Yeah, no, and I'll just make a comment. I won't drag it. Remember, we're not just offering network slice into 5G. There'll be other access networks, even broadband and everything else. If you make it specific to 5G, you'll have to spin another one when we start talking wireline and other services. So that's one. And this is, to me, looks like a mapping draft, not treatment. So maybe you can indicate somewhere that we're doing the mapping here, but we're not telling you how to do network slicing inside IETF. Maybe I missed it, but that's just comments, just for your draft.
Okay, maybe we can talk.
Thank you.
Offline as well. Yeah.
Harry Sangli. I've seen many documents who underplay transport network as part of the slicing story. So this is a good document, and I definitely agree that having transport network in the picture and having the end-to-end is implicit is definitely very good. So I support that.
Okay, thank you. Thank you very much again.
Christoph?
Hello, my name is Christoph Szarkiewicz from Juniper Networks. On behalf of co-authors of the draft realization of IETF network slices for 5G networks using current IPMS technologies, I will present our draft. So co-authors are from Orange, from Juniper as well, and from Orange, Med, from Telefonica, Luis, and from Ribbon Communications, Ivan. Next slide, please. So basically, the idea here, the overall goal and approach was that assess to what extent IETF network slice can be implemented using current IPMS technologies. So which means if we have current network running and the operator would like to introduce 5G services on this current network with minimal change, what the operator can do in order to introduce 5G services, and provide kind of reference document, kind of blueprint to approaches to deploy slices with such technologies. So what needs to be configured, what needs to be deployed, orchestrated, and so on. And then our approach was rather than generic claims. We pick a specific deployment context, which is the 5G. Yes, 5G is the most promising context here for slicing. That's the reason we pick 5G as an example for that. Next slide. And because this is concentrating on 5G, we are using terminology that is used in the 5G when we convert slicing, so RAN, CN, TN, so core network, transport network. It means we are talking about transport network slicing. And when we talk about transport network slices and transport slices, we refer to IETF network slice basically, but we are concentrating on the 5G terminology. So in 5G world, they are calling it transport slice. Next slide, please. So what we have in this document, so first is overview of 5G networking. This is for generating, transport engineers to understand more or less about 5G. Different kind of methods between the RAN, CN, and transport network. So how we handle the traffic, what is the cooperation here between these domains to the transport network? How do we realize the transport of 5G slicing using current IP/MPLS technologies? In order, for brownfield deployments, existing network, aligning the 5G concept of 5G deployments with the current deployments that we have, for example, business services, wholesale models that we are currently deployed, and so on. Then we touch very close about transport network slicing QS models. We define here two models, 5K aware, unaware, and 5K aware model. And we touch about capacity planning management. So basically the idea here is that we use capacity planning for traffic isolation. Next slide, please. So we define as well different mapping options between the 5G slice and the transport slice, which is IETF network slice as mentioned before. And there could be a couple of options. Some examples are provided here. So one-to-one mapping, one-to-N mapping. So we could have one transport slice that serves multiple 5G slices. We could have some 5G slice that's serving, different for the user plane, different for the control plane, and the user plane, control plane using different transport slices and so on. There are a couple of models described in this document. Next slide, please. Then we define as well, from the orchestration perspective, we see the differentiation between the first slice being deployed, 5G slice, and the subsequent slices, especially for the control plane. So usually the control plane is shared among multiple 5G slices. Next slide, please. There's one question, okay. Another high level overview of the realization model is that we are using very granular control on the edge, on the service delivery points, on the attachment circuits, and very rough, of course, QS control in the transport. This is to align with the current technologies and current deployments models that are used by the service providers. Next slide, please. We discussed different kinds of methods as mentioned. So at the moment, the initial version of the draft is draft 0. We described the VLAN handoff methods and the IP-based handoff methods. By the future versions, we describe additional handoff methods between the RAN, CN domain, and the transport network domain. Sorry, next slide, please. And as discussed, we discussed different QS models, QF mapping models, basically how to map the QS using the 5G, which is 5QI. 5G QS identifier to the QS used in the transport network. We define two models, 5QI unaware mode, which means the entire slice is treated as the single class from the transport network perspective, or 5QI aware mode, which means that we have some class differentiation in the 5G slice, and this class differentiation is reflected in the transport network. Next slide, please. And at the end, we use capacity planning and management. So there are a couple of schemes can be considered. We describe the schemes in details. I will not go details because we don't have time. Scheme 1 is the shortest path forwarding, so it's basically not traffic engineering or eventually some flex algo. Scheme 2 is traffic engineering with fixed path reservations. And scheme 3 is traffic engineering with dynamic bandwidth reservations, so it could be auto bandwidth or the reservation based on the telemetry collection. And of course, additional schemes can be considered as well. And the conclusion, so existing IETF technologies provide good foundation for implementing 5G slicing in IETF domain. And of course, in subsequent revisions of this draft, we'll expand that. Next steps, the questions, suggestions, and comments.
Hi, it's Adrian. Thank you for this draft, which I found a really detailed and well-written, useful backgrounder. However, I don't think that section 3 and section 5 are IETF material. They're really useful descriptions of how 5G works, but I'm not sure that the IETF is the place that we should be documenting that, even as an explainer to the IETF.
But section 5 is the traffic engineering, is the schemes. So maybe section 2 is describing the 5G.
Sorry, the section number's wrong. There are two sections. There's one describing 5G and one describing 5G QoS. And those I worry,
Okay.
you know, what's the consequence of them conflicting with 3GPP and
Okay,
so on.
okay.
So it feels more like a white paper, good to publish, but maybe not here.
Mhm.
The other thing I'd like you to consider is that using the default NRP is an approach, and it's certainly achievable. I'd like you to spend some time on describing the limitations of that approach as well as the benefits.
Okay, understood. Yes, we are that. Thank you.
I agree with Adrian. It's a good document, but I agree with Adrian. It's a good document. I strongly suggest that you use the terminology that we have in the framework. I see here transport network, transport slice, those things. We had a lengthy discussion during the adoption of the framework, and for the specific reason we don't want to use them. So please make sure that all the terminology that you use is conform with that draft. Thank you.
Thank you.
I think Groove left.
Fine, yes.
So I think that we're good there. There was a comment in chat about there's some overlap between this and the previous one.
Exactly, yes.
And
We will
maybe,
be touched,
I mean,
yes.
there is separate material, so maybe just reference rather than
Yep.
define.
All right. Thank you very much.
Louis?
Hello, everyone. I will present this draft about the data center aware T topology model on behalf of John and Sufen as co-authors. So next, please. Well, here the idea is that the service providers are deploying more and more computing capabilities across the network, being connected in several points of the network, several attachment points. And this relates to the data centers or compute capabilities of different sizes. So we can link this with the edge computing story or much more centralized data centers. So the problem that we try to address is that the fact that it could become interesting to have a joint topological view of the network plus the compute capabilities being connected on across the network, right? So in such a way that we could assist on the traffic engineering decisions once we need resources in the compute side. So here, what we do is to follow a similar approach to the one that was followed in another working group document, which is the service function aware topology model. So essentially, moving from the service function ideas to the resource idea of the compute capabilities. So the purpose here is to describe compute capabilities maybe in two manners. This is some work in progress, so we need to see if it's consistent to go in one direction or in another direction or in both of them. So one approach would be to describe the resources, I mean, to describe the data set, the compute capabilities in terms of resource capabilities, such as CPU, memory, storage, and so on so far, or alternatively, to describe them in terms of resource bundles, which is usually known as quotas. Here, for instance, we follow an example in the draft, which is being elaborated in the CNTT initiative as Cloud Infrastructure Telco Task Force, which is a joint initiative between the Linux Foundation and GSMA, just as an example. So next, please. So for instance, in this initiative, they are proposing different flavors, and they consider predefined flavors as the ones that you can see at the table, but they also open the door to define customized flavors. So somehow what we try to reflect here is these possibilities. So going to either the raw resources or either going in these ideas of flavors. And so we will try to adapt the model to these two approaches by now. So next, please. So as a summary, that was already presented in IETF 109. Versions 1 and 2 essentially provided updates on the model, on the idea of these compute flavors. This is also because the definition on these alternatives like the CNTT and so are moving forward. So somehow we are adapting to these new definitions. So as next steps, we would like to adapt the model to the different ways of exposing data center capabilities. This includes also different kind of technologies. For instance, the example that I saw before was defined in relationship with OpenStack in this CNTT initiative, but there will be other ways maybe of expressing resources with other approaches like Kubernetes and so. So our objective will be also to work on the YAM modules accompanying the model, and also probably to start including some examples, some cases that could better reflect the possibilities of this approach. We are considering, for instance, start modeling what could be a case for UPF or things like that, or thinking on the segregated radio as well, the CU and so. That could be examples of applicability of this model. So just for finishing, any feedback or any comment is more than welcome. And that's all from my side. Thank you.
Greg? Is Greg in the room? Okay, I don't see the presenter for this, unless Sampath, are you going to present? Someone just give me the cue. All right, we're going to try to go back to Bo. That was, Bo, can you check your audio while I find your slides, please?
Okay, can you hear me now? Is this better?
It sounds okay. Why don't we give it a shot? Did I get the wrong one? I got the wrong one. Sorry. Hold on a minute.
Okay.
7.
Okay, I try to be quick. Thanks, everyone. This draft has been presented for several times, and this time I'm going to give some updates on this draft. And since last IETF meeting, the working group has adopted the two new NRP-related drafts. And so when we had this, Tariq just mentioned we had some discussion with NRP modeling, and since still the NS framework gives some general NRP definition, we still think that NRP modeling needs more detailed definition. Like here, we try to summarize some key components from the two new adopted drafts. One is from NS IPM Plus, since there are so many new terminology in this draft, we try to find some common components that also in the NRP scalability draft. So here we think that NRP partition mode is quite useful to define different partition types, and also NRP control plane. In NS IPMPS, they define NRP TE, but in NRP scalability, they also define some distributed control plane like multi-topology and also FlexAgo. These distributed control plane can also be supported. And about the data plane, NRP data plane, NS IPMPS defined data plane selector and PHB. but NRP scalability defines like NRP ID for the data plane. So here we try to summarize the requirements and like to ask the comments and feedbacks from others and to see whether we have some good summation here. And about this model usage, we try to align with NS framework definition. This NRP model belongs to network configuration interface model. And then about this NRP topology, the terms we try to borrow from NS IPMPS network because right now there's no there's a need like whether this NRP topology needs to be defined. Like Tariq just mentioned, we have the filter ways to define a filter topology, but since we reading from the framework draft, we feel that there is another customized way that we can select specific links from the underlying network. Here on the right hand, I showed a model just a snip from the model that you can see that how that model topology can be set up instead of using the filter rules. So that's the main update from the last IETF meeting. And then here is a summary of the way we think about the NRP model component, the major components. Like basically, we feel the NRP model should cover both NRP configuration and also NRP monitoring. And for configuration, we can choose to decide whether this is a control plane partition or it's a data plane partition. And then about the topology, that's already in the NS framework definition. And I think resource reservation NRP policy also had this, but NRP control planes seems missing in NRP policy. So we think this is at this stage, we think this is a summary of the major components. I think, and then it's NRP monitoring and basically, Tariq also mentioned that right now we are still in the discussion, and since this model and NRP policy model, they have many comments. So we are still, I think at this time, we need more discussion to merge two drafts. So, but we like to hear more comments and reviews from working group to give us like suggestion on the NLP modeling requirements part. That's all. Thank you.
Any comments, questions? So you commented about having some relationship with the draft, the policy draft. It seems that there needs to be a really tight alignment between the two drafts because they're effectively controlling the same thing from different perspectives or from different locations. What are your thoughts on that?
I think right now we haven't have the like conclusion yet, but like from our side, we think that most of the components are quite common, like data plane, identifier, and all those components. So,
are you thinking about,
yeah.
Oh, go ahead. Go ahead.
Yeah, we think we need to merge into one draft, but keeping like filter or customized way as different options. So like we can cover different topology creation options, but that's what I think. Yeah.
Merging sounds quite sensible. Thank you.
Okay, thank you.
I think Greg is not in. Thanks, Bo. I think thanks to Greg, you get 1 minute back. Thanks everyone for a great session. See you all in London.
Thank
Thanks.
you. Thanks, everyone.
Thank you all. We